In this video, we're going to solve a uniform motion problem. Trina and Candace live on the same street and study together at the library directly between their houses. It took Trina 2/5 of an hour and Candace 1/5 of an hour to walk to the library. Trina walks 2.5 miles per hour slower than Candace. We want to find both women's walking speeds. So one of the things that's really helpful for me is to draw a quick picture of what's going on. So if we have Trina's house here and Candace's house over here, then we know that their library is going to fall directly between the two houses because that's what the problem told us. So we can draw essentially just a line to connect them, and we can say that the library has to be right in between. So I'm going to put L for library. That means that they are actually the exact same distance from the library. So let's say that the distance Trina is from the library, we'll say that's Trina, is the distance D, and Candace is the same distance away. If that's the case, then that actually makes it a much easier problem than it at first appears, because when you're looking at it, you're saying, well, I don't know how far away they are. How am I supposed to know this? The key is that they are the same distance away from the end point. So we do have an equation for distance. Distance equals rate times time, where rate is just another word for their speed. Now we know that Trina is going to take 2/5 of an hour. So Trina's time is 2/5. And we know Candace has a time of 1/5 of an hour. We also know that Trina's rate, we could just call it capital T. And Candace's rate, we could call capital C. But they gave us a little bit of extra information here. Trina walks 2.5 miles per hour slower than Candace. So that means that Trina's speed is really C minus 2.5 because she's moving more slowly. So that actually is all the information that we need because we know that the two distances are the same amount. So when we're looking at Trina, we can say her distance is her rate, which is the C minus 2.5, times the time, which is 2/5. And we can do the same thing with Candace. Her distance is her rate, which is C, times her time, which is 1/5. And because these two equations have the same distance value, we can actually set them equal to each other, or think about it like you're substituting the second equation into the first. That means we are now solving the equation 1/5 C equals 2/5 times C minus 2.5. I did bring the fractions out in the front of each piece, just so it's a little bit easier to see where it is. Now, to solve for Candace's speed, we're going to start by distributing the 2/5. So I have 1/5 C equals 2/5 C minus, and 2/5 times negative 2.5 is -1. Now we want to get Candace by herself, get the C value by itself, so we'll subtract 2/5 C from both sides. That gives us -1/5 C equals -1. To finish solving for this value, we'll multiply both sides by -5. This gives me that C equals +5. Or in other words, Candace is walking at 5 miles per hour. So what about Trina? Well, we know that Trina's speed is Candace's speed minus 2.5. So 5 minus 2.5 equals 2.5. So we know that for both women's walking speeds, Candace walks at 5 miles per hour and Trina walks at 2.5 miles per hour.